All right, this question here is question 16 from the 2025 NHT exam. All right, so this one here is asking us now for a precedence table. So we need to fill in the values for Q, R, and S. Now for the values for Q, R, and S, so Q depends on two variables here. We've got N and P. So N, comma, P. Now the variable R depends on one variable, which is P, and the variable S, activity S, depends on M only in this case. So we've got M. Okay, we've got them up. Now the next question says, what's the earliest start time and what's the latest start time, and what activities have a float time that is not zero? So we're going to do those three questions in one hit. So in order to do that, we need to do something called forward scanning and backward scanning. Now, in order to do forward scanning and backward scanning, what I'm going to do is I'm just going to draw little boxes. Okay, boxes on the nodes. Some of you might like to draw boxes on the activity line itself. That's okay. Okay, and I'm going to draw three boxes for the start. You'll see why shortly. I might draw this one above. Okay, this one here, I'll draw them there. And I might draw another box here, because that's depending on that activity. Okay, so is there any other boxes that I need to consider? Okay, I might draw another box up here as well. Okay, so let's go through forward scanning to work out the earliest start times of each of these things. What we're going to do is we're going to draw zeros, zeros, and zeros here, because there is no point delaying the project if we can start it at this point. So activity M. Activity M, we can start this at 10 after activity M will finish at 10, and we can start activity S or T at 10. However, what we need to do is we need to be careful of the fact that there is another activity that is running here, which is NQ or even PQ, which will take 11, because 4 plus 7 is 11, which means that this entry here, or this activity, can't start until both NQ and PQ are complete, and it can't start at 10, so therefore it needs to start at 11. Okay, because we always take the highest value when we're trying to find and we're doing forward scanning. Okay, so the next one here is activity P will finish after 4, so that means R can start after 4, and activity N will depend on P, so that can start after 4, and we've done the first component here. Now, activity T can start at 11, okay, but because because NQ needs to be completed, NQ and then T. Now the next one here, activity R. Activity R will take 4, so 4 plus 4 is 8. Okay, so from that point, we now just need to work out the rest of it. So if we go down this top path, 11 plus 17 is 28. I'm going to write 28 outside the box because I don't know if there's a longer time that will take. Next one is 11 plus 4, which gives us 15. 15. Now, I'm going to be careful with this one as well. Luckily, I know 8 plus 7 will give us 15. If that was a higher number, I'd need to take that into account. Now, the next one here is 8 plus 12, which is 20. Again, I need to be careful because I'm going to write 20 on the outside, because 15 plus 6 actually adds up to 21. So 20 is actually not the earliest start time, it's 21. Now that I've got all those values, I've got 21 plus 8, which is 29. And this other one here, 15 plus 12, which is 27, which means that 29, and my latest start time will be 29 as well. So that's forward scanning. This is a bit more of a complex example, so if you're not familiar with this, I'd suggest going back to less scaled back version. Now, okay, now let's do some backward scanning. Now, with backward scanning, we want to choose the lowest value when we come across at crossroads. So let's go through that now. So 29 take away 8 will give us 21. Okay, there's no other intersecting sort of node going there, so that's okay. We can be sure that that's 21. Now, this going back this way, 29 minus 17 will give us 12. Okay, 12 will go there. Activity S, there's really no other pathway for that one. It's just from S straight to finish, so we can be confident that's 12. Now, when we've got 29 here, we can go backwards from X and we get 17. Okay, and from here, if we go down and then back up, activity W will be 21 minus 6, which is 15. Okay, and so that's why we've got two boxes here, because if we went through activity X, we've got 17, but if we go through this way and we end up at this node, we've got 15. Okay, now the next one here is, I'm going to have to draw in another box here as well. Sorry, got. So that's 8. Sorry, 8. Okay, so 17 minus 7 is equal to 10. So 17 minus 7 is equal to 8. But keep in mind, so 17 minus 7 is equal to 10, but keep in mind we want to use the smallest value from each node. So we're going to do 15 minus 7, which is 8. And you can see with the bottom path, we've got 21 minus 12, which is 9. And then from here, to work out this one, we're going to go 8 subtract 4, which is 4. And then if we go to the top one, we go 15. So this node, take away 4, gives us 11. Okay, and then from here, we've got 4. So 11 subtract, so 11 subtract 7 gives us 4. And 11 subtract 10 gives us 1. And then 4 minus 4 gives us 0. And 4 minus 4 gives us 0. So if we answer the questions now, we can say that the earliest start time of activity W is here, is 15. Latest start time of activity X is over here. Latest start time is 17. And which ones have an activity of flow time? We've got activity M, activity S, activity X, and activity V. Okay, so those are the 4 activities that will give us that don't have flow time. Now, the last question is a crashing question. Now, in order to crash, what we need to do is you need to write out all possible options um, with parts. Now, my clip champ keeps on crashing, so you'll probably see my working here is already started. I'm gonna have to erase all this and do it again. So, stay tuned. So, in order to crash, what you need to do is you need to write down all possible options. So when I say all possible options, I mean you literally go through this chart and you go MS, MT, X, MTW, Y. And you can see with this one here, we've got all possible options. Now with all these possible options, you have to add up all the possible options path length. So you can see here, our critical path will actually be the ones with the highest value. In this case, it's the 29s. Now, the information in this question says to us, you can reduce the completion time of any activity by exactly 1 week only. So that's why I've got this list here of the letters on the side, because we're going to make a check to see whether or not we've crashed them or not. And then we're going to add them all up. So let's do this right now. So in order to crash, we should be removing we should pretty much be trimming the highest value and the activities from those highest activities, so that we continually get a new critical path, but we'll keep trimming it down if we're allowed to. So 29, we're going to crash these 29s first. So 29, what's common between the first one and the second one? So in this case, we've got, I don't know, let's crash P because it looks like P. Yeah, looks like it will reduce a lot of values. So this one here will be 28, 27, 26, 28, 26, 27. I'm going to note down that P has been crashed by 1. Okay, now the next thing is we've got a 29 still up here. So a 29 with the top value will mean that I need to keep crashing. So let's crash maybe Y. So Y. So that becomes now 28. That becomes 27. That becomes 26. And that becomes 27. So my critical path has been reduced now. So it's no longer 29. All right, let's keep reducing now the 28s. So 28s, I've got N. Let's reduce N. So N, 27, N, 26, N, 27, and any other N's. So N and Y. So I should have noted that down, that Y. So reduced. Okay, let's reduce another letter. So our 28s have been all reduced. Then we've got 27s. Let's reduce the 27 and let's reduce maybe S. So S becomes now 26. S, 26. 26. Any other S's? No. Okay. 27s. Looks like there's still other ones. Let's reduce the maybe the W value. Let's see what happens with the W value if we reduce it. So 27, 26, 26, 26. Okay, W value. Okay. 26s now. Let's see if we can keep going to get the values further down. So let's reduce Q. If we reduce Q, Q, 25, Q, 25, Q, 25. Okay, so Q can be reduced. So now we've got 25s all over. Let's reduce R. 1, 2, 3, 25, 25, and 25. Now, there's only one critical path existing here, which is the M's. Now, the M, if I reduce M by 1, that becomes 25. But the thing is that now that I've reduced and exhausted all possible options with the top one, 25 will never be any less than what it is right now. 25 is the absolute lowest, which means that any other subtractions that I make with any other path, like if I crash U, V, or um, T or X, it'll be redundant because the top path will never be less than 25, which means that if I look at all my crashings, I've got a total of 8 crashings. So 8 times 2,000, which is equal to 16,000. And what is the minimum now completion time? 25. Okay. All right, and that should answer that crashing question.